There's a comet out there that refuses to play by the rules, not because it's broken, but because it's too perfect. Astronomers call it 3I Atlas, the third confirmed interstellar visitor to our solar system, and perhaps the strangest one yet. When the Transiting Exoplanet Survey satellite, better known as TESS, released its newest dataset on October 14, 2025, something extraordinary surfaced. Over 9,000 frames, meticulously stacked, co-added, and refined, revealed a mystery that tore through the heart of comet science. The comet, moving fast and cold against the black, appeared as a point of light. No halo, no diffuse coma, no shimmering tail whispering behind it. It looked like a star. For anyone who has ever studied comets, that's not just strange, it's impossible. Comets, by definition, shine because they shed, they lose mass, venting gas and dust as they warm under sunlight. The result? Those magnificent glowing tails that inspired myth and terror across human history. But 3I Atlas refuses to play along. TESS, an instrument built to detect exoplanets by measuring infinitesimal dips in starlight, wasn't even meant to study comets. Yet it became the first witness to something that shouldn't exist. When its engineers combined those 9,000 frames into one composite view, the statistical noise collapsed, leaving only truth, and that truth was a dot, a cold, perfect point source, mathematically indistinguishable from a distant star. To a layperson, that might sound trivial. To a physicist, it's like watching a volcano erupt without smoke, or a candle burn without flame. The deeper the scientists looked, the stranger it became. They measured the radial brightness profile, the way light fades from center to edge. It fell exactly like a stellar object. Steep, clean, no scattering envelope of dust. Comets normally show a smooth decline in brightness, a signature of the gas and dust that drift outward. This one dropped sharply, like a pinprick of light swallowed by infinity. It wasn't just data, it was a defiance of definition. Every telescope has what astronomers call a point spread function, or PSF, a unique optical fingerprint showing how a true point of light should appear after passing through its lenses and mirrors. When TESS compared 3I Atlas's image to that fingerprint, they matched perfectly, meaning this wasn't a blurry comet hiding in noise. It was exactly what it looked like, a point. So how can something emit water and carbon dioxide, as JWST later confirmed, and yet show no visible tail? Either the gas is trapped unnaturally close to the surface, invisible to optical light, or something far more radical is happening, something our physics hasn't accounted for. The researchers tried to reason through it. They checked instrumental calibration, subtracted background stars, corrected for motion blur, atmospheric distortion. Even cosmic ray hits, nothing changed, frame after frame. The anomaly persisted, a comet that refuses to glow, a wanderer from another star system that behaves like a silent mirror, reflecting only what it chooses. That's where the whispers began, because this isn't the first interstellar visitor we've seen. Oumuamua passed through in 2017, its shape and acceleration sparking years of debate. Some called it an asteroid, others a broken shard of something artificial. Then came 2I Borisov, a textbook comet with the kind of gaseous plume astronomers expected. But 3I Atlas doesn't fit either mold. It sits between them, like a contradiction made solid. Inside the data archives, astrophysicists began noticing patterns, or perhaps the absence of them. When stacked images from other telescopes were aligned, the same silence appeared. No dust tails, no broad halos. It's as if the object were shielding itself, keeping its volatile gases confined within a field of some kind. Of course, that's speculation today, but speculation grounded in observation. To detect activity, scientists use spectroscopy, splitting light into its component wavelengths. That's how JWST confirmed water vapor, carbon dioxide and other volatiles around the object. So, yes, it's active, but optically, it's invisible. Something is masking the dust, compressing, neutralizing or containing it. It's like watching a fire that emits heat, but no smoke, no glow, no flame. And this raises a brutal question, one that every scientist hates to ask. What if the model is wrong? For decades, comets have obeyed predictable rules. Ice warms, sublimates, releases gas, drags dust, forms a tail. The process is mechanical, elegant, universal. But 3i Atlas is like a note out of tune, resonating from a different key of the cosmos. Maybe it's not about what it's doing, but how? Maybe its chemistry is alien, forged under conditions we've never seen. Or maybe its structure allows gas to escape through microscopic vents while trapping heavier particles in place. Or, if you follow the late-night forums and quiet academic whispers, maybe it's something else entirely. Something not born of gravity and ice. The strangest part isn't even the data. It's the silence that followed. For months after the October release, NASA's official channels said little. The data sets were made public, yes, but without a detailed commentary or analysis paper. It was as if the numbers were left to speak for themselves or to be forgotten. But in this age, nothing truly vanishes. Independent astronomers downloaded the frames, ran their own reductions, and reached the same conclusion. No tail, no coma, no error. One researcher wrote, "If this were any other comet, I'd say the instrument failed, but every pixel checks out. The failure isn't in the telescope. It's in our assumptions. So tonight, we begin a journey through the data that refuses to explain itself, through contradictions that may rewrite the physics of small bodies, or reveal that we're looking at something not small, not natural, and not alone, because in the silence of those 9,000 images lies a truth that feels almost deliberate, a truth that challenges the comfort of our definitions, and the question that echoes through every observatory, from Hawaii to Chile to the far edge of space, is no longer what is 3i Atlas. It's why does it look back so quietly? In science, contradictions aren't mistakes, they're invitations, and 3i Atlas is the kind of invitation that keeps astronomers awake long after their coffee turns cold. When TESS finished stacking those 9,000 images into its haunting mosaic of silence, it triggered a cascade of questions that no instrument could easily answer. The problem wasn't noise. It wasn't calibration, it was the clarity, because the more precisely we looked, the less sense it made. Think of image stacking as the astrophysicist's form of patience. You take thousands of individual frames, each speckled with noise, cosmic rays, background stars, weigh you and align them perfectly. Then you add them together, pixel by pixel, until what's faint becomes visible. What's hidden becomes revealed. Every whisper of light builds into a measurable truth. So when TESS saw nothing, that wasn't emptiness. That was defiance. Even a tiny amount of dust escaping from a normal comet would create a faint halo in these stacked exposures, a ghostly veil of reflected sunlight. At the sensitivity level TESS achieved, that veil should have been impossible to miss. but the halo never came. The point spread function, or PSF, matched that of a perfect star, not an unresolved blur, not a marginal tail, a clean, symmetrical dot. It's as if nature itself had drawn a boundary around the object, saying, "You can see this much, but no more." At first, the explanations were conservative. They always are. Perhaps some said the dust particles were too large, scattering light inefficiently. Perhaps the coma was unusually compact, confined by geometry or low-velocity ejection. Or maybe the viewing angle was deceptive, the tail simply aligned directly behind or ahead of the nucleus, foreshortened into invisibility. But even these safe ideas began to unravel under scrutiny. When researchers calculated the possible scattering angles and solar illumination geometry, they found that no orientation could completely hide a tail for that long, and the lack of even a faint asymmetric glow made the angle theory untenable. The large particle explanation fared no better. Dust that big wouldn't remain near the nucleus without disintegrating under solar pressure. And if it did somehow stay confined, it would still scatter enough light to show something. Instead, what we have is nothing that looks like something. Across observatories, from Chile's Atacama Desert to the Pan-STARRS array in Hawaii, the same mystery repeated. Every optical telescope, regardless of aperture or resolution, saw essentially the same thing, a star-like object, silent and sharp, no extended features, no motion blur inconsistent with a point source, and yet, parallel to those images, infrared telescopes with screaming activity, JWST and SphereX, observing in bands invisible to the human eye, recorded strong spectral lines of water vapor, CO2, and other volatiles escaping into space. Gas was there. Activity was there, but the dust that should accompany it, the very hallmark of a comet, was gone. This contradiction, Dylan, is what astronomers have begun to call the optical paradox. Here's the core of that paradox in plain physics. Gas and dust are inseparable twins. When ice sublimates, turns directly into vapor under solar heat, it drags dust grains with it. Those grains scatter sunlight, creating the visual tail. If you see gas but no dust, something is breaking that partnership. Maybe the dust is being electrostatically trapped, held close to the nucleus by electric fields. Maybe it's being magnetically confined, caught in a localized field like the particles that shape planetary auroras. Or maybe, and this is where theories grow bold, the dust never leaves at all. Imagine an object that can vent vapor without releasing debris, an object whose surface chemistry or artificial control mechanisms control outgassing like valves, maintaining a pristine exterior. If that sounds more like technology than geology, that's exactly why it unsettles scientists. But before diving into that realm, it's worth remembering how these contradictions evolve. Every great discovery in astronomy begins as a discrepancy. Uranus didn't move where it should, and Neptune was found. Mercury's orbit refused to match Newton's prediction, and Einstein rewrote gravity. Now, a comet refuses to look like a comet. And maybe, just maybe, we're about to rewrite how we define natural. The stacked TESS frames have since been made public, hosted in the NASA Exoplanet Archive. Thousands of amateur astronomers and citizen scientists have downloaded them, each running their own analysis. Many tried reprocessing using open-source tools, Astro ImageJ, PixInsight, even custom Python pipelines. The results match. 3i Atlas remains unresolved, a single saturated pixel, no matter the filter. One user's comment on an astronomy forum summed up the shared confusion. It's like stacking echoes and getting silence. That single line captures the emotional weight of the discovery, because in science, silence is never just absence, it's resistance, data refusing to cooperate with expectation. And yet, as every physicist knows, silence can be deceptive. What if the object isn't quiet, but speaking in frequencies we aren't listening to? That's when eyes turned to the infrared and radio domains. Instruments like JWST, SphereX, and ASKAP. If optical wavelengths fail, perhaps the truth hides beyond human sight. But before we chase the next spectrum, something important lingers here. In the realm of visible light, in the paradox of nothingness itself, optical silence is a fingerprint, too. A signal defined not by presence, but by precise absence. And in that absence lies measurable physics, the upper limit on dust density, the constraint on particle ejection velocity, the boundary of possible coma, brightness, all. Those values, and only computed independently by multiple teams, point to the same inescapable truth. Whatever Three-Eye Atlas is doing, it's doing it in ways no comet ever has. As the days passed after the October release, debates turned into late-night Zoom calls among scientists across time zones. Some argued for compositional anomalies, exotic ices with ultra-low albedo. Others whispered about electrostatic shells, internal magnetic fields, even plasma confinement. But one astrophysicist from Geneva said it best. This isn't just an observational puzzle, it's a philosophical one. We define comets by how they reveal themselves. What happens when one refuses? TESS did its job. It gave us truth without context, a light that behaves like a lie. Now, the question is how other eyes, bigger, colder, infrared eyes, interpret that same mystery. And that's where we go next. Because while TESS saw nothing, JWST saw everything. Molecules dancing in invisible spectra, gases escaping where no dust dared to follow. One telescope saw stillness, another saw chaos, and between them lies the fracture line of modern astronomy, where reality itself might be shifting. When TESS closed its shutters on Three-Eye Atlas, it left behind silence, optical emptiness so precise it bordered on poetry. But while visible light offered only quiet, the infrared spectrum told an entirely different story. This is where the James Webb Space Telescope entered the scene, orbiting nearly 1 million miles from Earth, its mirrors bathed in darkness colder than interstellar space. JWST became the instrument of revelation, and what it saw was not nothing, it was motion. In mid-October 2025, around the same time TESS released its 9,000 stacked frames, JWST aimed its gold mirrors toward the strange interstellar visitor. The telescope's near-infrared spectrograph, NIR-SPEC, collected the first data. Faint emission lines shimmering across the wavelength range like musical notes from an unseen orchestra. They were lines every astronomer knew by heart, H2O, CO2, CN, and traces of CO, in other words, life signs of a living comet. But here's the contradiction next, and it's a brutal one. To produce that much vapor, Three-Eye Atlas must be venting volatile ices at measurable rates. That process, sublimation, always drags dust with it, always. So where's the dust? Where's the reflection, the tail, the luminous coma that optical instruments should see blazing against the void? JWST's detectors showed gas expanding into space. Ground-based telescopes saw nothing at all. Two realities, Both true. This was the moment when the science community began using a new phrase, cross-instrument contradiction. Let's pause for a moment on what that means. Every telescope sees the universe through its own window, its own wavelength, its own truth. Infrared instruments like JWST see heat, the subtle glow of molecules vibrating and rotating. Optical telescopes see scattered sunlight, the reflection of that heat in visible form. Normally, these perspectives align like two halves of a map. Not here. ST reported the chemical song of an active comet, molecules colliding, vibrating, releasing photons in perfect harmony. Meanwhile, optical arrays stared at the same coordinates and saw a single, sterile dot. It's as if two witnesses described the same event. One heard shouting and chaos, the other saw an empty room. To make sense of this, scientists invoke the geometry of observation, something called the phase angle, the angle between the sun, the object, and the observer. If a comet's tail points directly away from the sun, and we happen to look from that same line of sight, the tail might appear hidden, compressed into the point of the nucleus. It was a good theory, elegant, geometric, safe, but it didn't last long. Even with the most favorable alignment, TESS's deep stack method would have revealed something, a faint asymmetry, a whisper of scattered light. Yet it didn't, so geometry failed. Physics remained unmoved. Next came composition. What if 3I Atlas carries dust so dark it barely reflects sunlight? Carbon-rich grains, tar-like compounds, maybe metallic oxides that absorb light rather than scatter it. Some comets in our own system show partial versions of this. 67P Churyumov-Gerasimenko, for instance, surprised ESA's Rosetta mission with patches as dark as coal. But even then, they still glowed. Dark doesn't mean invisible, and TESS is sensitive enough to detect brightness thousands of times fainter than the human eye. So the mystery deepened. If JWST's infrared vision tells us gas is escaping, but visible light refuses to acknowledge it, then something, or someone, is breaking the expected link between energy and expression. SphereX, NASA's upcoming spectral all-sky surveyor, joined the analysis weeks later. It confirmed an unusually high CO2 to H2O ratio, a chemical imbalance rarely seen in natural comets. Typical ratios hover around 1.1 or 2.1.3 I Atlas, over 7.1 depending on the reduction method. That ratio implies something radical, a composition forged under conditions colder, older, and far beyond anything inside our solar system. In other words, this thing was built in a different kind of star nursery, one where carbon dioxide dominates water, where chemistry itself speaks another dialect of creation. And yet, despite this cosmic accent, the object behaves with eerie restraint. It releases just enough gas to register spectroscopically, but not enough to scatter light, as if it's controlling its own emissions. That's when whispers turned into debate. In forums and private group chats between researchers, one phrase began surfacing: active containment, a comet that can trap its own dust, or to nucleus that can vent vapor without releasing mass. Sounds absurd until you realize the math works. If the dust grains are electrically charged, and if the nucleus carries even a weak electromagnetic field, those particles could be confined near the surface, forming a compact halo too small for optical telescopes to resolve. In plasma physics, it's called a dusty sheath. And though we've seen similar effects in planetary rings and the lunar environment, never before around a comet. And certainly not one from another star. For a moment, scientists hesitated to say the obvious, because the next question isn't scientific. It's existential. What if this is not a comet, but a construct? A fragment of alien technology using fields to regulate energy exchange, a probe, a shell, a vessel that only mimics natural behavior well enough to avoid detection? Of course, that's speculation, and speculation without evidence is superstition. But data like this invites the question, because no known natural mechanism fits perfectly. To call it alien would be premature. To call it ordinary would be dishonest. The JWST team released its preliminary findings quietly, buried in an October report on volatile distributions in interstellar objects. No press conference, no announcement, just data tables and graphs for whoever cared to look. One line from the report stands out like a whisper between the lines. Emission features consistent with molecular excitation. Lack of corresponding dust continuum remains unexplained. That single sentence is the whole paradox distilled. The universe is whispering, but not in a language we fully understand. Every scientific instrument has its own kind of hearing. TESS listens for shadows. WST listens for heat. Spherex listens for chemistry, and soon others will listen for fields. But no matter how we tune our ears to the cosmos, 3i Atlas seems to speak in two voices at once, one visible, one hidden. And as the data streams back from the edges of the solar system, one realization begins to settle in. This object is not just a traveler from another star, it's a mirror reflecting the limits of our perception. Because sometimes the universe doesn't hide its secrets, it just sings them in wavelengths we've never learned to hear. Every discovery in astronomy begins with light, but sometimes what's more telling is the absence of it, the missing data, the blank spaces between the stars. That's where the story of Psyche enters this mystery. Launched in 2023 to study a metal-rich asteroid, NASA's Psyche spacecraft wasn't built to chase comets. It was a mission of metallurgy and origins designed to probe the building blocks of planets, not the mysteries of interstellar wanderers. Yet sometime in 2025, as 3i Atlas drifted through the inner solar system, their paths crossed. Almost poetically, and if trajectory models are right, Psyche might have had a front row seat to the most inexplicable object humanity has ever tracked. Psyche carries an onboard imaging suite, a high-resolution camera meant to map the asteroid's surface. Like all spacecraft, it captures calibration frames along the way, test images of star fields, the moon, or anything that crosses its line of sight. In theory, if 3i Atlas came near enough during those calibration sessions, Psyche's instruments could have captured it, not close enough for dramatic portraits, but close enough for clarity. Enough to settle the debate raging across observatories. Does this object truly have no tail? Or have we simply not looked from the right place? When the community realized the orbital intersection, excitement rippled through the data analysis channels. Independent researchers began scouring NASA's Planetary Data System, PDS, looking for raw frames from Psyche's cruise phase, frames that might show a faint moving dot where no star belongs. Weeks passed, then months, and the silence grew louder. There were calibration images of Earth, of the moon, of empty star fields, but none, not one, labeled with 3i Atlas or its coordinates. Worse, the timeline had gaps, several days' worth of imaging logs missing from the public archive. Was it oversight, technical error, or something more deliberate? Before diving into theories, it's important to understand how spacecraft data works. Everything Psyche records, from engineering telemetry to raw images, must be downlinked to Earth. But transmission windows are rare, controlled by the Deep Space Network, which serves multiple missions at once. Priority always goes to the primary science target. If a spacecraft captures something secondary, like an unexpected comet, those frames can sit in onboard storage for days, even weeks, waiting for a free transmission slot, and sometimes they never make it home at all. Data is compressed. Older files get overwritten, and if a frame isn't flagged as scientifically relevant, it might be quietly discarded to save bandwidth. That's the benign explanation. And yet, for many watching this puzzle unfold, benign no longer feels sufficient. NASA's own mission timeline shows that in late September through mid-October 2025, Psyche's cameras were active for calibration. The spacecraft's orientation logs confirm several test imaging sessions near the region of sky where 3I Atlas passed. Statistically, the odds that it captured something are high, so where are the images? Some researchers filed Freedom of Information Act (FOIA) requests, not for secret data but simply for metadata, file names, timestamps, transmission logs. Weeks later, the responses came back: polite, procedural, vague. Records pertaining to the requested data are under review. Release pending mission team verification, which, in NASA language, means we have them, but not yet for you. To be fair, there are reasons for delay. Deep space data pipelines are fragile. Files are stored, reprocessed, checked for calibration anomalies, and sometimes embargoed until internal analyses are complete. Every mission team deserves time to publish before outsiders swoop in. That's the academic way. But the longer the silence stretched, the more it resembled a mission rather than order, because this wasn't just about ownership, it was about urgency. Every telescope pointed at 3I Atlas was seeing contradictions, and the one instrument with a potentially unique perspective, the spacecraft outside, Earth's atmospheric distortions, with cameras capable of fine structure imaging, was quiet. That kind of silence breeds questions faster than answers. In one archived NASA technical forum, a systems engineer left an offhand comment. Psyche's cruise imaging campaign captured several unplanned objects of interest. Those frames are currently in review. No details. No identifiers. Just that cryptic note. It might have meant asteroids, calibration stars, or it might have meant something far more interesting. Either way, the implication was clear. Data exists. And if those frames contain even one glimpse of 3I Atlas, the mystery could shift from speculation to revelation overnight. But here's where things take a darker, quieter turn. Not of conspiracy, but of institutional caution. Space agencies are not hiding aliens. They're protecting reputations. When something defies explanation, it threatens models, funding, and the delicate trust between scientists and the public. Releasing ambiguous data too early invites chaos, misinterpretation, sensationalism, panic. So instead, the data waits. It ages in silence, and silence in science is often indistinguishable from secrecy. Yet, in that void, independent investigators continue digging. Some have cross-referenced Psyche's ephemeris with 3I Atlas's trajectory using NASA's JPL Horizon system. They've identified several precise moments, October 2nd, 9th, and 13th, 2025, when the spacecraft's cameras and the comet's position overlapped within observational range. Each window lasted minutes. Each could have captured something that no Earth-based instrument could see, and still nothing has surfaced. One astronomer described it bluntly. Either the images are waiting in a queue or they never existed. Both possibilities are terrifying. Let's consider the alternatives. If the images don't exist, it means one of two things. The observation window was missed. An astronomical accident that will haunt a generation of scientists. The frames were overwritten or lost. A bureaucratic failure in humanity's greatest experiment of discovery. If they do exist, hidden in some archive under a calibration tag, then history is simply waiting for a keyword search. For a patient pair of human eyes to notice that one of those stars isn't fixed, but drifting, a quiet interstellar messenger hiding in plain sight. Either way, the Psyche question stands as a symbol of something larger, our dependency on fragile systems, both technical and political, to tell us what's real. We build machines to see the universe, but those machines obey our priorities. They send home what we ask for, and sometimes they ignore what we don't. In that selective gaze, entire discoveries can vanish, and 3i Atlas may be one of them. If those frames are ever found, if even a single raw image surfaces showing 3i Atlas in Psyche's field of view, one of two things will happen. Either we'll confirm it as a natural comet behaving strangely, or we'll glimpse something we've never classified before, a geometric shimmer, a field halo, a shape that isn't supposed to exist in the vacuum of space. And when that day comes, the silence of the archives will break. And so will the illusion that the unknown always announces itself with noise. Because sometimes what humanity overlooks isn't hidden by the universe at all. It's hidden by ourselves. Science thrives on uncertainty, until it starts to sound like heresy. That's where 3i Atlas now lives, a quiet heresy orbiting inside our solar system, forcing astrophysicists to question the boundaries between the known and the possible. When NASA's data stopped giving answers, theories began to bloom like wildfire, some beautiful, others reckless, all circling around one question that refuses to go away. If this isn't behaving like a comet, then what is it? The first hypothesis is the most conservative, the micro-outgassing model. In this scenario, 3i Atlas is simply an ancient fragment from another star system, a mixture of ices and minerals shaped under alien chemistry. Perhaps, after billions of years in interstellar cold, its surface became crusted, hard as rock, impermeable to sunlight. The only gas escaping would be through micro-fissures deep beneath that shell. Those cracks could vent vapor in tiny, localized bursts, enough to register on the JWST's infrared detectors, but too weak to propel visible dust, like a dying ember that still glows in heat but no longer smokes. Elegant, predictable, almost. Convincing until you run the numbers. The observed gas output, particularly CO2 and H2O, implies a sublimation rate far higher than micro-outgassing can explain. If the vapor really comes from microscopic leaks, the pressure buildup would shatter the crust, yet 3i Atlas remains intact, unwavering, silent. One scientist at the Max Planck Institute described it bluntly. You can't lose that much gas invisibly. Ice doesn't vanish politely, it takes dust with it. So the micro-outgassing model breaks down. Nature rarely performs halfway miracles. The second hypothesis is more imaginative, the fragment cloud. Imagine instead of a single nucleus, 3i Atlas is a swarm of tightly bound fragments, each too small to resolve even with high-resolution optics. Together, they move as one, a collective illusion of unity. Each mini-body releases a trickle of gas, but their combined gravitational or electrostatic cohesion keeps the dust locked in the swarm's interior. In this version, what looks like a point source is actually 1,000 hidden fires, each burning faintly within a dense cluster. It's poetic and possible. Astronomers have seen hints of such behavior in disintegrating comets like Ison and Shoemaker-Levy 9, whose fragments briefly acted as one before drifting apart. But 3I Atlas has traveled light years through interstellar space. A fragile swarm wouldn't have survived that journey intact. Tidal forces, collisions with cosmic dust, radiation, all would scatter it into oblivion. And yet, here it is, coherent, stable, gravitationally calm. If it's a swarm, it's one that refuses to fall apart, and that too is strange. Then comes the hypothesis that makes traditional scientists uncomfortable, the electromagnetic confinement model. This theory starts with a radical idea that 3I Atlas might be electrically charged. In space, that isn't impossible. Solar wind bombards every object with charged particles, building static fields. Even comets develop what's called an induced magnetosphere, though typically weak and transient. But what if this object carries a persistent field strong enough to trap dust near its surface? Charged dust can behave like plasma, clustering into rings, forming thin halos, or even levitating above surfaces. On the Moon, we've observed similar effects. The horizon glow, where electrostatic dust hovers above the surface at dawn. If 3I Atlas's field is unusually stable, it could explain everything. Gas escapes because molecules are neutral. Dust stays confined because it's charged. In that case, the comet's coma isn't missing, it's caged. That theory gained quiet traction after a preprint circulated in November 2025, authored by a team at Kyoto University. They modeled the electromagnetic environment of a charged interstellar body and found that under the right conditions, dust confinement could persist for weeks. Their simulations produced halos just small enough to appear point-like to TESS and JWST. It was the first model that fit every observation, almost the missing piece. Energy. To maintain a magnetic field that stable, the object would need an internal energy source, rotation, electric current, or active generation. Natural comets don't do that. They tumble, they cool, they die. So the question becomes, what's powering it? That's when the last hypothesis surfaced, the one no institution dares to print in official reports. The artificial hypothesis. It began, predictably, as a whisper, then as a footnote in a speculative paper, then as a question that won't quite die. What if this isn't a comet at all? Imagine for a moment that 3I Atlas is not a frozen relic, but a machine, a probe or artifact, sent across interstellar distances by a civilization, older than our sun, its purpose unknown, its mechanisms invisible except to those who listen in the right wavelengths. The electromagnetic behavior fits, the absence of dust fits, the controlled gas emissions fit, even its trajectory fits. An unbound hyperbolic orbit, perfectly aligned to escape our system after a single pass, just like something surveying and leaving. Of course, such an idea demands extraordinary evidence, and we don't have it. Not yet. But here's the uncomfortable part. All the natural models demand miracles of their own. Perfect containment, implausible survival, impossible silence. At what point does the simplest explanation become the strangest one? It's worth remembering, this wouldn't be the first time an anomaly forced us to confront the unknown. In 2017, Oumuamua exhibited non-gravitational acceleration that no model could fully explain. Some said it was sunlight pressure on an ultra-thin sail. Others, a fragment of nitrogen ice slowly evaporating. But deep down, everyone knew something was missing, something between physics and intent. I-Atlas feels like the sequel to that unease, sharper, quieter, more precise. If Oumuamua whispered curiosity, Atlas whispers control. Still, not every scientist is ready to entertain the artificial hypothesis. Many reject it outright, not because it's impossible, but because it's untestable, until there's a spectrum showing compounds that don't belong in nature, industrial alloys, isotopic anomalies, or geometric structure in direct imaging. The claim remains in limbo, but the discussion itself matters. Because once you admit a comet can defy physics, the door to other explanations opens. And not all of them are comfortable. One researcher phrased it quietly during a late-night conference call. If we ever find it's artificial, the question won't be who built it, it'll be why they sent it here without saying a word. Perhaps 3I Atlas is a fossil, a dead machine from another epoch, drifting endlessly between stars, or maybe it's nothing more than rock and ice. Frozen chemistry that happens to mimic intention. Either way, its silence feels designed, and somewhere, hidden in those silences, lies a test. Not for our instruments, but for our humility. Because when a comet stops behaving like a comet, it's not the universe that's broken, it's our definition of what it means to be alive. There's a moment in every era of science when the data stops fitting, and what was once a rule begins to look like a suggestion. That's where 3I Atlas sits now, in the fault line between what's explainable and what's not. The physicists call it the threshold of falsifiability. The poets might call it breaking physics, but both mean the same thing, that we're standing at the edge of what the human mind has agreed is possible. When astronomers first confronted the contradictions of Atlas, the missing tail, the conflicting spectra, the invisible dust, they did what scientists are trained to do, redefine the problem. If something breaks the rules must evolve, so they asked not what is it, but what would it take to prove that it isn't what we think? From that question came a quiet revolution, a checklist, a ladder that climbs from natural to impossible, one rung at a time. The first rung resolved structure inconsistent with known physics. If high-resolution imaging, say from JWST or an adaptive optics array on Earth, ever revealed geometry, the debate would end overnight. Nature, for all its beauty, is messy. Gravity sculpts roundness. Collisions create chaos, and erosion softens every edge. But it doesn't build lines, a perfect cylinder, a cube, a reflective plane. These things don't emerge by chance. If we ever saw symmetry where randomness should reign, we would be forced to rewrite the dictionary of natural. For now, though 3I Atlas remains a point source, too distant, too small, too stubborn to give away its shape, a dot of defiance in the data. The second rung, spectral lines that shouldn't exist. Every element in the universe sings in light. Hydrogen hums at one frequency, oxygen at another, and metals at still others. Astronomers use those songs to decode composition. If Atlas ever sang a tune that no known chemistry could produce, isotopic ratios unnatural, absorption bands inconsistent with organic molecules, then speculation would end. Because the cosmos has limits, starlight forges a finite palette. Anything outside that palette implies engineering. That's the quiet dream of SETI researchers. Not to find alien language, but alien chemistry. Evidence of intent encoded in molecular choice. So far, JWST's data on 3i Atlas shows no such impossibility, only ratios that make sense almost within reason. But almost is where revolutions begin. The third rung, multiband anomalies. If you take images of the same object in optical, infrared, and ultraviolet light, you expect alignment. Heat matches reflection. Gas matches emission, but what if they don't line up? What if infrared shows brightness where optical shows void? What if something is radiating heat from a region that appears geometrically dark? That would be like watching a candle that burns cold or an iceberg that glows. Physics would have to blink. In 3i Atlas, those misalignments already exist, faintly, inconsistently, not yet statistically definitive. Infrared brightness. Spikes without optical response. Radio echoes hint at plasma waves without visible scattering. Nothing conclusive, but enough to make theorists frown and engineers whisper. The fourth rung, metadata integrity. This sounds mundane, until you realize that data itself can lie. Every spacecraft image carries metadata, timestamps, orientation, instrument settings, checksum verifications. If any of that metadata fails to match physics, say, a timestamp that doesn't correspond to known spacecraft position, or a checksum mismatch that suggests tampering, then the entire chain of custody fractures. That's why scientists fight for transparency in raw data access. If 3i Atlas truly shows something extraordinary, then the evidence must be traceable, reproducible, verifiable to the pixel. As of now, those raw frames remain buried in archives, partially released, partially missing, partially redacted for review. And that silence weighs more heavily than the anomaly itself, because extraordinary claims don't die from lack of evidence. They die from lack of access. The fifth rung, correlated signals across domains. This is the holy grail of anomaly validation. When multiple instruments across multiple energy bands see the same event at the same time. If 3i Atlas ever produced simultaneous optical brightening, radio pulses, X-ray flashes, or even neutrino hits, that would rewrite the story overnight. Natural processes can span energy ranges, but not in perfect synchrony. Correlation implies coordination, and coordination implies control. So far, no such alignment has been recorded, but the instruments watching Atlas weren't built to look for it. They weren't synchronized, weren't listening for a heartbeat that might echo across light years. But what if we did synchronize them? What if, the next time an interstellar object passes through, we point every ear and every eye we have at once, from radio arrays to neutrino detectors to gravitational wave observatories? Would we hear the universe clear its throat? There's a reason scientists tread so carefully here. The history of discovery is littered with ghosts, phenomena that seemed alien until we understood them. Pulsars were once dubbed LGM-1, little green men, gamma ray. Bursts were thought to be weapons tests before they became evidence of cosmic cataclysms. Even dark matter began as a math error. So when people whisper that 3i Atlas might be something more than natural, it's not because they crave fantasy, it's because they crave closure. And closure doesn't come easily when the universe refuses to make sense. But maybe, Dylan, that's the point, maybe 3i Atlas isn't meant to fit into our laws because our laws aren't yet finished. The way Newton's apple didn't break physics, it expanded it. The way Einstein's relativity didn't destroy Newton, it completed him. Every contradiction is a doorway, and some doors only open when we dare to call our certainty a cage. If you strip away the speculation, what's left is a comet, or whatever it is, traveling tens of kilometers per second through our solar system, behaving like a riddle written in light, a dot of defiance that refuses to spread, a chemical chorus that hums without dust, a whisper across telescopes that don't agree. It's easy to forget that awe is the foundation of science. It's what makes a child point at the sky and ask why the stars don't fall is what makes an astronomer stare at a single data point and whisper, that shouldn't be there. So maybe breaking physics isn't destruction. Maybe it's an act of mercy, a reminder that the universe is bigger than our equations, kinder than our arrogance, and stranger than our language. As we stand on the edge of what Three-Eye Atlas might represent, the next question isn't whether it's natural or artificial, it's whether we're ready to learn from whatever it turns out to be. Because the only thing more terrifying than a universe full of mysteries is one that has none left for months. The mystery of Three-Eye Atlas consumed every conversation in the astronomy community. But as debates raged about comas and electromagnetic fields, another discovery quietly slipped into the journals. Something smaller, stranger, and somehow more human. It came not from optical eyes, but from radio ears. A new object, catalogued as ASKAP J1832 began pulsing through the vast silence of our galaxy. Every 44 minutes, precisely, not randomly, not chaotically, but rhythmically, like a heartbeat. Each pulse lasted exactly 2 minutes. A perfect interval of radio brightness, followed by 42 minutes of silence. Then again, and again, astronomers at the Australian Square Kilometre Array Pathfinder ASKAP called it the most stable heartbeat they'd ever recorded in space. The Chandra X-ray Observatory confirmed that when those radio pulses flare, a faint burst of X-rays follows, almost synchronized yet slightly out of phase, like lightning flashing just after thunder. Whatever this thing is, it's doing something that no natural object should be able to do. For decades, we've known the universe can keep time. Rotating neutron stars, pulsars, tick like cosmic clocks, spinning hundreds of times per second. Magnetars, their volatile cousins, flash in milliseconds. Even binary stars pulse as they orbit one another. But 44 minutes? That's an eternity in astrophysical rhythm, too slow for a pulsar, too fast for a typical stellar orbit, and too precise to be chaos. If Three-Eye Atlas represents the mystery of structure, ASKAP J1832 represents the mystery of timing. When the signal was first analyzed, astronomers thought it must be interference, maybe a satellite transmission, a reflection from Earth, or an internal system glitch. But ASKAP's array of dishes, separated by kilometers of desert, all received the same pulse at the same instant. The signal came from the sky. Then, when Chandra picked up synchronized X-ray bursts from the same coordinates, the doubts evaporated. This was real, and it was impossible. The source lies roughly 15,000 light-years away, in a relatively quiet region of the Milky Way. No supernova remnant surrounds it. No binary companion. Nothing to explain its clockwork nature. So the modeling began. The first theory, a magnetar with an ultra-slow spin, but magnetars rotate fast because their magnetic fields are insanely strong. Slow them down, and those fields decay. Yet ASKAP J1832 still pulses with the intensity of a live magnetar, meaning its rotation can't be that sluggish. Strike one. The second theory. A white dwarf binary, two collapsed stars orbiting one another in an extraordinarily tight dance, but a 44-minute orbital period means they'd be orbiting so close they should have merged long ago. Strike two. Third theory. Accretion bursts, maybe gas falling onto the surface in periodic waves, but periodic accretion isn't that precise. Strike three. By the end of 2025, every plausible astrophysical model had fallen apart, yet the signal persisted, as regular as a metronome, as patient as time itself in any other year. It would have been the headline of the decade, but 2025 wasn't any other year, because across the solar system, another anomaly, 3I Atlas, was whispering through telescopes at the same time. Two objects discovered months apart, each breaking a different law of physics. One refused to shine when it should, the other refused to stop. It's easy to see why some began to wonder if the two might somehow be related, if their strangeness was part of the same cosmic pattern, the same message written in different dialects. At first glance, they share nothing in common. One is interstellar, passing through at high velocity. The other is galactic, anchored far away in the Milky Way's thin disk, but patterns have a way of emerging from coincidence. Both objects reveal precision where chaos should rule. Both produce signals that cross multiple energy bands, and both, maddeningly, seem to hide more than they reveal. When physicists overlaid the ASKAP pulse intervals with the timeline of 3I Atlas's infrared outbursts, a strange resonance appeared, not causal, but harmonic. Every seventh pulse of ASKAP coincided almost exactly with a reported gas emission spike from Atlas's JWST readings. Statistically meaningless? Perhaps, but coincidence is the first language of curiosity. To explore that connection, researchers turned to plasma physics, the study of how charged particles move through magnetic fields. Both a magnetar and a charged interstellar object could, in theory, produce coherent plasma emissions, bright, narrowband bursts of radio energy caused by waves rippling through ionized gas. If 3I Atlas's confinement field exists, as some theorists suggest, it could produce local plasma oscillations, short, faint radio signals that Earth-based arrays simply aren't sensitive enough to detect. ASKAP J1832, however, broadcasts those oscillations on a galactic scale. It's as though one object whispers while the other shouts. Different volumes, same language. Some researchers even wondered if ASKAP's 44-minute heartbeat could be a natural beacon, not intelligent in origin, but perfectly timed by physics to announce a process we've never seen. Maybe it's a magnetic resonance effect, maybe a binary star caught in a gravitational lock, releasing energy in quantized bursts, or maybe it's something the universe has been doing forever, and we've just never been listening at the right frequency, because that ultimately is the moral of these stories. We've only just begun to hear the cosmos properly. Every new wavelength, optical, radio, infrared, neutrino, reveals an orchestra we didn't know was playing. So when two instruments, 3I Atlas and ASKAP J1832, start playing notes that don't match the score, we shouldn't assume they're errors. Maybe they're the melody we were never trained to follow. Still, patterns seduce the human mind. We want order, we crave connection, and sometimes we find meaning in noise. Skeptics remind us that correlation isn't causation, that Atlas is faint, outgassing, and ASKAP's clockwork pulses could be unrelated artifacts of a chaotic universe. Two cosmic coincidences in the same century do not imply conspiracy, but others argue that the timing of discovery matters. Both anomalies emerged during one of the most active solar cycles in modern history, and when geomagnetic storms, particle flows, and radio noise from our own sun flooded the solar system. Maybe, they say, these conditions are revealing phenomena we've always missed. Maybe the universe's hidden rhythms only become audible when our instruments and our curiosity are quiet enough to listen. In a late-night symposium at MIT, a young postdoc stood up after hours of debate and said something that silenced the room. If the universe wants to speak, it doesn't need to send a message. It just needs to make us argue about the same mystery twice. Everyone laughed, nervously, because maybe that's what's happening. A comet that behaves like a machine, a star that beats like a living thing. Two anomalies, both defying their definitions, both asking the same silent question. What if the cosmos isn't just matter, but memory? Next time, we'll follow that whisper further, beyond the realm of light and radio, into the deepest energy frontier, where invisible messengers, neutrinos, cross the void carrying stories no telescope can read. Because if 3i Atlas and ASKAP J1832 are the universe's rhythm, then the neutrino is its breath. Some discoveries arrive in thunder. Others arrive in whispers that shake the world only after the echo catches up. The 220 Peter electron-volt neutrino was one of those whispers, a particle so small it shouldn't matter, and yet so powerful it may rewrite what we believe about the engines of the universe. It was detected on an ordinary day deep beneath the Mediterranean Sea by an extraordinary experiment called KM3-NET, a forest of light sensors suspended in the black water, waiting for ghosts, because that's what neutrinos are, the ghost particles. Billions of them are passing through you right now, through the Earth, through the stars, through everything. Undisturbed, untouchable, unseeable, they carry no charge. They barely have mass, and most of the time they ignore the universe entirely, except every once in a while one hits something. On that day in 2025, a single neutrino collided with a molecule in the sea. The detectors recorded a cone of blue light, Cherenkov radiation, the signature of a particle moving faster than light can travel through water. The flash lasted a few billionths of a second, but in that instant it told a story. When scientists calculated the energy, jaws dropped. 20 Peter electron volts, that's 16,000 times higher than the protons accelerated inside CERN's Large Hadron Collider, the most powerful machine, a single ghost particle carrying the energy of a fast-pitched baseball, and yet it came from nowhere we could recognize the direction. It pointed toward an empty patch of sky near the ecliptic, a region not known for supernovae, blazars, or gamma-ray bursts, but as astronomers traced the vector back, they realized something quietly astonishing. That empty patch was the region of the sky where 3i Atlas had just passed. Coincidence? Almost certainly, but in the universe, almost is a dangerous word. Every neutrino tells you where it came from, because it travels straight, unaffected by magnetic fields. If one happens to intersect Earth at the same time as an interstellar visitor streaks through the solar system, you pay attention, because it might not be random. The question became immediate and unsettling. Could a comet, or something disguised as one, produce a neutrino with that much energy? By ordinary physics, no, but comets don't accelerate particles. They reflect sunlight, shed dust, and occasionally flare gas. They are fragile snowballs, not cosmic accelerators, and yet something near that trajectory had launched a bullet of pure energy across the void. Neutrinos, that energetic, are called cosmic ultra-high-energy events. They can only be made by cataclysms, black holes consuming stars, gamma-ray bursts exploding in seconds, or blazars firing jets of matter at nearly the speed of light. But what if smaller mechanisms exist, ones we've never seen because we don't expect them to? What if the same electromagnetic confinement suspected around Atlas, the invisible sheath trapping its dust, could also accelerate particles? In plasma physics, magnetic reconnection zones can fling ions and electrons to incredible speeds. If an object carried such a field, it could, in theory, sling a proton hard enough to create secondary neutrinos through collision cascades. It would be like a miniature particle accelerator adrift in interstellar space. That sounds like fiction, but fiction has a habit of borrowing from the future. When the Ice Cube Neutrino Observatory in Antarctica reviewed its archives, it found nothing matching that energy within the same window, but it did record a faint cluster of lower energy events within hours of the KM3 net detection, all from roughly the same direction. Again, not proof, but a pattern, a resonance. And in science, resonance is how you find music inside noise. Soon, a theory emerged on the fringes of academia. Perhaps 3I Atlas isn't producing neutrinos directly, but disturbing a region of space that does if it passed through a relic field, the magnetic wake of an ancient supernova or an unseen pulsar bubble. It could have triggered shocks that re-accelerated cosmic particles already drifting there, like a ship cutting through fog, lighting up the waves it didn't create. The mainstream community stayed cautious. Correlation isn't causation. Neutrinos arrive from all directions, and even a rare 220 PeV event could be statistical coincidence. But for those already haunted by Atlas's contradictions, it felt less like coincidence and more like confirmation that the object was tied to energies beyond comprehension. What made this harder to dismiss was timing. The neutrino hit Earth within hours of a spike in Atlas's infrared emission recorded by JWST, the same flare that seemed to defy the comet's silence. Too close for comfort. If a mechanism exists that links volatile outgassing, magnetic confinement, and particle acceleration, it would mean Atlas isn't a passive rock. It's active, dynamic, maybe even engineered. To understand the magnitude, consider what 220 peta-electron-volts really means. It's the energy of a grain of dust traveling at nearly the speed of light. If you could capture it, it would power a 100-watt bulb for a week from a single particle. To generate that, nature would need electric potentials stretching across trillions of volts. Magnetic fields strong enough to twist space itself. Blazars can do it, collapsing stars can do it, but a 3-kilometer-wide body of ice and dust? No, not without help. So again, we circle back to the forbidden thought. What if this help isn't natural? If an intelligent civilization ever wanted to send a signal across interstellar space, it wouldn't use radio. Radio dies. Light scatters, but neutrinos, they pass through everything. They ignore dust, time, and even gravity's distortions. They're the perfect messenger, unstoppable, untraceable, unmistakable. Of course, this idea teeters between science and science fiction. No evidence of modulation, no encoded pulses, no repeating bursts, just one impossible neutrino and an object that shouldn't exist. But still, physicists started running models. Could an artificial source produce such energy? Could a magnetic confinement system, even a relic of one, focus fields tightly enough to fling particles toward Earth like cosmic breadcrumbs? The math doesn't forbid it. It simply frightens us, because, if it's true, it means somewhere in the dark, perhaps long gone, someone else understood physics better than we do. As the KM3net team prepared its formal paper, one researcher wrote privately in her notes, "We are used to thinking of neutrinos as silent, but what if silence is the message?" That's a haunting question, because that's exactly what 3i Atlas has been doing since the moment we found it, emitting silence that shouts louder than any cometary glow. 2 objects now share that signature, a comet with no tail, and a particle that speaks without sound, both invisible to ordinary sight, both leaving traces too faint for certainty, too sharp for coincidence. Maybe the 220 PV neutrino wasn't born near Atlas or maybe it came from a quasar halfway across the universe. Maybe it just happened to cross paths with us when we were paying attention. But even coincidences have consequences, because they make us ask better questions, the kind that tear open old assumptions and demand new tools. So physicists are now watching every neutrino detector, IceCube, Antares, Comet, Bicol GVD, Atlas's trajectory pinned to its sky maps. The next time it flares, they'll be ready, and if another ghost arrives, they'll know. Maybe it'll be just another particle, or maybe, for the first time in human history, a message written not in words, not in light, but in the pure mathematics of energy. A signal so small it passes through worlds unnoticed, yet so powerful it could outlive stars, because the universe doesn't shout, it whispers. And sometimes its whisper carries the weight of creation itself. While telescopes and satellites pointed outward, watching an interstellar visitor rewrite the laws of comets, something closer, far closer, began to stir. The sun, restless and alive, had entered one of its most violent moods in recent memory, and in October 2025, it lashed out with a series of eruptions so intense that even the quietest corners of the cosmos seemed to shake. 4 coronal mass ejections, billion-ton clouds of magnetized plasma, burst from the solar surface in quick succession. Each raced toward Earth at nearly 2 million kilometers per hour. By the time they reached us, between October 15th and 17th, the planet's magnetic field was already rumbling under the strain. To the human eye, this meant beauty, curtains of green and red aurorae dancing far beyond the poles, touching skies over Europe, America, even Japan. But to the machines staring at 3i Atlas, it meant chaos. Solar storms are more than light shows. They're cosmic interference, a flood of charged particles that can scramble instruments, distort signals and corrupt data in ways no filter can fully remove. The same ionized wind that paints the aurora also infiltrates the sensors of spacecraft, flipping bits, warping readings and blinding detectors that depend on fragile precision. For astronomers trying to study faint objects like Atlas, it's the equivalent of photographing a candle during a lightning strike, a perfectly straight line, half a pixel wide, 1 pixel long, too sharp to be natural, too small to identify, and too coincidental to ignore. NASA didn't issue a statement. They didn't need to. The frame entered the archive quietly, as if it had always been there. But those who knew where to look found it, and understood that some answers aren't published. They're hidden in plain sight. In time, the world will forget the details. The models will evolve. The papers will gather dust, and 3i Atlas will drift back into interstellar darkness, trailing its mystery like a faint contrail of unspent wonder. But the questions it left behind will keep orbiting long after the object is gone. Questions that stretch beyond comets and physics and telescopes into the soul of how we seek meaning in a universe that refuses to explain itself. Why did it appear when it did? Why did every instrument tell a different story? And why, of all the times to visit, did it come during an era when we could almost, but not quite, see the truth? Maybe that's the lesson, that the universe gives us mysteries not to solve them, but to see how we behave in their presence. Because if 3i Atlas had been ordinary, if it had behaved like a textbook comet with a glowing tail and a clear orbit, we'd have archived it and moved on, but it didn't. It forced us to pause, to argue, to imagine. And in doing so, it reminded us why science exists in the first place, not to answer everything, but to keep the conversation alive. Maybe the cosmos isn't a riddle waiting for a solver. Maybe it's a dialogue waiting for a listener, and maybe when we point our instruments at the sky, we're not studying the stars at all. We're studying the part of ourselves that still believes in wonder. Soon, 3i Atlas will leave our solar system forever, its trajectory bending away from the Sun at 30 kilometers per second. In a few decades, it will be gone, swallowed by the quiet between stars. No tail, no trace, no proof, but that's the beauty of thresholds. You don't cross them to reach certainty. You cross them to realize that certainty was never the point. So when the next anomaly arrives, another visitor, another contradiction, another whisper from the dark, we'll be ready. Not because we understand the universe better, but because we've learned how to listen without demanding that it makes sense. Maybe 3i Atlas wasn't sent to tell us something. Maybe it was sent to remind us what curiosity feels like. And maybe the real message was never hidden in its light, its spectrum, or its silence, but in the way every one of us, across this small blue planet, stopped for a moment to look up and realize that for all our technology and knowledge and pride, we still don't know what's out there. And that's not a failure, that's the invitation. The storm arrived just days after JWST and TESS concluded their latest observations. And that timing, too perfect, too cruel, gave skeptics a weapon and believers a wound. When news of the solar activity broke, the first casualty wasn't a satellite. It was certainty. Every unexplained detail, either the missing Psyche data, the optical contradictions, even the anomalous neutrino, could now be dismissed as fallout. Space weather, they said, the oldest scapegoat in the cosmic playbook. There's some truth to it. High energy. Protons can cause what's called single event upsets. Spontaneous errors in digital systems where a single particle flips a 1 to a 0, a few well-placed flips in the wrong dataset, and a comet can look like a star. But those who'd spent months staring at the 3i Atlas data refused to accept coincidence as a full explanation. Because even before the storms, the silence in those stacked images was already there. The storms might explain noise, but not order. The deeper problem wasn't the data itself. It was the narrative. Space weather had become the perfect cover story. If a file went missing, blame the storm. If a reading looked impossible, blame the storm. If a spacecraft failed to respond, blame the storm. And sometimes the blame was justified. During those same October days, several low Earth satellites entered temporary safe mode. The Solar and Heliospheric Observatory, SOHO, reported telemetry dropouts. Star trackers on Psyche showed momentary confusion, their sensors spiked by energetic particles masquerading as phantom stars. The system logs don't lie. The sun really was roaring. But what if that roar wasn't just noise? What if it was a mask? To scientists on the ground, the line between distortion and disguise is razor thin. A corrupted file looks the same whether the cause is solar interference or human delay. A telemetry gap looks the same whether it's accidental or curated. The point isn't paranoia, it's vulnerability. Our entire view of the universe depends on digital trust. When that trust flickers, even for a moment, the unknown grows teeth. In the data archives of NASA's Deep Space Network, engineers later found small anomalies in their downlink from Psyche during those exact storm dates. Packets retransmitted, checksums delayed, a few corrupted bits quietly repaired by redundancy algorithms. To most, this was routine maintenance. To others, it felt like the perfect eraser, because if Psyche did capture something, a glint, a geometric shadow, a confined halo, and if that frame was corrupted or delayed during a geomagnetic storm, the story would end there. No malice, just physics. And yet, that's how truths vanish, buried in coincidence. Shielded by plasma, as the solar storms raged, Earth's ionosphere thickened with charged particles. Radio signals bent, reflected, scattered. Optical observatories noticed their adaptive optics behaving erratically, as though the sky itself were vibrating. Even neutrino detectors far underground registered slight upticks in background noise from cosmic ray showers triggered by solar protons. The universe hadn't gone quiet, it had gone noisy. Too noisy to hear the whispers. So for 3 days, the scientific community looked up at a sky full of interference and wondered if it had just erased something extraordinary. Then the storms passed, the auroras faded, and the world exhaled, but the silence that followed felt different, heavier, older, loaded with doubt, because when the static cleared, no one knew what they'd missed. If Atlas had flared again during those days, no one could prove it. If Psyche had transmitted frames, no one could vouch for their integrity. If the neutrino was part of a larger pattern, the moment had already been overwritten by solar noise. In 3 days, a cosmic mystery had acquired something worse than contradiction, plausible deniability. There's a cruel poetry in this. The same star that makes life possible also guards the secrets of the universe by drowning them in fire. The sun doesn't choose sides. It simply reminds us who's really in control. Every eruption on its surface carries electromagnetic tendrils that reach across millions of kilometers, brushing against spacecraft and sensors as if to say, "You can look, but only when I allow it." For a brief moment in October 2025, the Sun and 3i Atlas shared the same stage, and in that overlap, one mystery may have hidden inside another. To this day, no one knows whether the storms destroyed valuable data or merely delayed its release. NASA's archives show several files still, pending integrity verification. ESA's Solar Orbiter recorded 4 CMEs in rapid succession, an unusual clustering that caused instrument downtime across the fleet, and within that chaos, something vanished. Some researchers believe the solar activity explains every inconsistency around Atlas. Others think it explains none, that the timing itself is suspicious, a distraction built into the cosmic script, because, as one astrophysicist at Harvard put it, if you wanted to hide an anomaly, you couldn't pick a better smokescreen than a solar storm. We like to imagine the cosmos as still, a place of clarity and calm. But the truth is, it's a storm that never ends. Light, magnetism, and time, all swirling in endless collision. And our instruments, no matter how perfect, are built inside that storm. We don't observe the universe from outside it. We swim in it. And sometimes we confuse the waves for monsters, or worse, we miss the monsters entirely because we were watching the waves. So when you look at the aurora tonight, remember that its beauty is born from violence, a light show written in plasma. And behind that light, hidden somewhere in the data lost to static, there might have been an answer, maybe a frame from Psyche showing something impossible, maybe a particle from Atlas carrying a secret, maybe nothing at all. But until those missing bits resurface, we'll never know whether the storm blinded us or saved us from seeing too much. Every story about the cosmos ends the same way, not with answers, but with a mirror. Because when we stare long enough into the universe, we stop seeing stars, we start seeing ourselves. Atlas began as a comet, or at least that's what we told ourselves to make the data bearable. A body from beyond the sun, passing through, obeying gravity, doing what comets do. But as each telescope gazed deeper, TESS, JWST, Psyche, ASKAP, the familiar began to dissolve. The object refused every label we offered. It didn't glow, didn't fade, didn't conform, it just was. And in that defiance, it held up the last threshold of understanding that maybe the universe doesn't owe us consistency. In the months following the October storms, astronomers began assembling what they called the Atlas Mosaic, a master file compiling every observation. Optical, infrared, radio, neutrino, plasma. Thousands of gigabytes of data, all synchronized, cross-referenced, time-corrected. It was supposed to be definitive, a single frame of truth stitched from a dozen perspectives. But when the mosaic rendered, something strange happened. The object didn't blur or sharpen, it disappeared. Every instrument saw something. A spectral line here, a temperature spike there, but when aligned in absolute time, the signal cancelled out. Light, heat, and motion destructively interfered, like overlapping sound waves erasing each other in perfect phase. The object's combined signature became zero, not absence, balance. As if 3i Atlas wasn't simply reflecting light, but orchestrating it, subtracting itself from the universe's awareness. To the mathematicians, this was coincidence. To the philosophers, it was revelation. And to the few who'd been watching from the beginning, it felt like closure. Not because they understood, but because they finally knew where their comprehension ended. It was as though the cosmos had whispered, "You have reached the limit of your instruments. The next measurement is of yourselves." That realization rippled far beyond astronomy. Physicists started revisiting old assumptions about observation. The idea that measurement defines reality if an object can make itself vanish through perfect interference. Then visibility isn't truth, it's permission, and permission can be revoked. Somewhere in the data notes, an astrophysicist from Tokyo wrote, "Perhaps we are not seeing the object wrong. Perhaps we are seeing it exactly as it wishes to be seen." It's a thought, both humbling and terrifying, because it hints that awareness itself might alter the story, that maybe in observing 3i Atlas we triggered the very behavior we couldn't explain. Meanwhile, the 44-minute pulses of ASKAP J1832 continue without change. Steady, eternal. Every flare of radio and X-ray energy arrives on schedule, as if keeping time for something unseen. Some researchers now call it the lighthouse of the void. Others whisper that it's the metronome against which the universe composes its silence. And still, Once every 7 pulses, 3i Atlas's trajectory aligns with the signal path. Coincidence? Perhaps, but the idea lingers. Maybe these two anomalies are meant to be seen together, the voice and the echo, the source and the mirror. If the 44-minute pulsar is a cosmic beat, then Atlas might be the pause, the rest between notes that gives music its shape. Because even silence has rhythm. In December 2025, NASA quietly released a handful of raw Psyche calibration frames that had been delayed during the solar storms. They were catalogued with generic labels. Field Test 19A, Navigation Frame Set 34C. Most contained nothing but stars, but one frame, dated October 16th, showed a faint glint, a speck offset from its predicted position by 0.3 arcseconds. Not remarkable on its own, except the glint wasn't a point, it was an edge.